This is a selection of AQA past paper questions. They're all multiple choice, and it's the fifth in the set that are based on the amount of substance topic. I'm going to recommend you pause on each question, try to get to the right answer, and then I will talk through how we get to that right answer. Okay, so let's jump straight into the first one. And in this, we've got the equation for the reaction between zinc and HCl. We're told the minimum mass in zinc that's needed to react with 50 cm cubed of the 1.68 molar hydrochloric acid. So we have got for the HCl a volume and a concentration. If you have that, always go on to work out the number of moles. I've got that here, and remember I am converting my cm cubed to dm cubed because my concentration is in decimeters cubed. Now that takes me to 0.084 moles. We're actually more interested in the zinc. So my moles of HCl and moles of zinc, I have got a 2-to-1 ratio. 1 mole of zinc reacted with 2 moles of HCl. So my moles of zinc that I started with are 0.042. And if I've got the 0.042 and I have got the atomic mass of zinc, 65.4, I can multiply those together and that will take me to 2.75. Now that's 2.75 grams. So we've got to read the question carefully. The question is asking for the minimum mass in milligrams. So we've got to multiply that by 1,000. So the correct answer is actually C. On to the next question. And on here we've got lead chloride. We're given the MR. We have a mass and a volume of the lead chloride. And we want to know the concentration of chloride ions in this solution. Again, a big question for 1 mark, but that's often the case in the mathematical multiple choice questions. I've got a mass and I have an MR. So let's work out the number of moles of lead chloride. 1.08 over 278.2 gives us 0.0039 moles. Now, if I've got the moles and I have got a volume, I can work out the concentration of lead chloride. So my 0.0039 moles are in 100 cm cubed. I've converted that to 0.1 decimeters cubed, and that takes me to 0.039 moles per decimeter cubed. But we're still not there. That will take us to answer C, but we've not finished yet. Because actually we don't want to know the concentration of lead chloride, we want to know the concentration of chloride ions. We're told that the lead chloride is PbCl2. If that dissociates, we get 2 Cl- ions for every PbCl2. So from that 1-to-2 ratio, we can actually see that the concentration of chlorine is the 0.078. And that's rounded slightly differently from the calculation, but correct answer D. On to the next question. And on here, we've got a volume, we've got a concentration of ammonia, and we want to make a different concentration of ammonia. How much water do we need to add? Again, we need to really consider what's being asked for here, but we can start off in a very straightforward way. My concentration and my volume, going to multiply them together, and that tells me that I've got 0.005 moles of ammonia. Now, I know how many moles there are, and I know what concentration I want to have. So if I've got moles and concentration, I can work out what volume of solution I would need. 0.005 divided by 0.05. And that takes me to 0.1 decimeter cubed. 0.1 decimeter cubed converted into centimeter cubed is 100 cm cubed. But don't fall into the trap of giving answer C, because the question asked, how much water should the student add? We already had 5 centimeter cubed, so 100 take away 5. The correct answer is 95 cm cubed. Next question for you. And this is essentially like a titration calculation. I have got for HCl a concentration and a volume. I'm converting my volume into decimeters cubed as always, and I've got 0.003 moles of it. I then need to look at the equation. Now we can see that HCl is monoprotic, and we can see barium hydroxide is dibasic, but we can actually write out the equation and balance it to see that ratio clearly. The barium hydroxide to hydrochloric acid is a 1:2 ratio. Now, if that's the case and I've got 0.003 moles of HCl reacting, I will need half the amount of barium hydroxide. So that's 0.0015. Once I know the number of moles, I can divide that by the concentration that we know that barium hydroxide had. And that then means that we can work out our volume, which is 0.0075 dm cubed. I need to multiply that by 1,000 to get to cm cubed, 7.5 cm cubed, and the answer is D. Final question, which has the largest atom economy? Now, you can go through and do the atom economy calculation for each of these, and I am going to start them off, but let's have a look at a potential route through that will quicken this one. Straight away, I'm going to get rid of B. I can disregard it, because if atom economy is where H2 is the useful product, ZnCl2 I know is a huge molecule. It's much bigger than carbon monoxide, so my atom economy is going to be very small. And you can work it out if you want to, but it will be much, much smaller. In terms of the actual relative molecular masses, I've added those in so we can see them, so we can start to do a little bit of maths. So in the first one, we have 2 divided by 28. On C, we have 6 divided by 28. And on D, we have 2 divided by 44. Now, I could go through and do those calculations, but 6 over 28 is clearly the bigger value, and therefore it has the bigger atom economy. That takes us to the end of this selection of questions. Thank you for listening, and goodbye.